Hello, ladies and gentlemen. Welcome once again to our virtual classroom. Today's lesson is going to be focused on multiplying fractions with grids. And by now, it has been established that my handwriting is not the most legible. So let me type that in for you. Multiplying fractions with grids. And not that we're going to be doing a lot of this today, but it is something that that I know has come up in the past. We just never had enough time to really flush this out, and it is something that you are expected to at least be familiar with, and you will be tested on this. And so again, we're not going to be doing a lot of this even today, but since today we are doing Activity 5, it is a bit of a review about everything having to do with multiplying fractions. I want to show you what this actually looks like. Now, before we begin, I do want to draw to your attention to the problems that we're supposed to be doing today. I have excluded numbers 2 and 15, so do not worry about numbers 2 and 15. You're only to do numbers 1, 4, 6, 8, 9, and 10, 12, and 13. Okay, so again, 1, 4, 6, 8, 9, 10, 12, and 13. I encourage you to pause this video at this moment, even as you are copying down the heading. Remember, this is our 12th lesson. And not only do I encourage you to copy down the numbers, but also go to your textbook, go to your OneNote, and circle the numbers that you are required to do. So again, pause this video and then resume the video once you are ready to begin. So as we multiply fractions using grids, let's just remember how to multiply fractions, which by now I expect is pretty simple. Let's be honest, multiplying fractions is not difficult. What people seem to have an issue with is really simplifying those fractions once we have the right numerator and denominator. But if you understand the multiplication process, you're doing good. You're doing good. Even if your grades are not the best on Schoology, remember, simplifying fractions is one of the hardest things that we're going to be doing this year. And again, it's not that it's hard, it's just figuring out what do we divide by. But with that in mind, let's do this problem. 2/5, it's a very ugly looking 2, times 2/3. Okay? And so the most basic way that we multiply this is we do numerator times the numerator and denominator times the denominator. So 2 times 2 is going to give us 4, and 5 times 3 is going to give us 15. And actually, that is simplified already. That is in simplest form. I don't have to go on. Okay, so that is true. When I multiply these two fractions, that is going to be my answer, 4/15. Now, what I want to do is use these two fractions to make a grid and shade in the grid following what the fraction tells me. This is what I mean by that. So the first fraction that we have here is 2/15. I have 2/5. 2/5. So that means that one side of the grid is going to have a total of 5 rows. That is the denominator. That is the total number of rows that I'm going to have. So I'm going to count 1, 2, 3, 4, 5. And I'm going to make a line that covers those 5 rows. Obviously, I've already done that. But there's the 5. And to make the other side of the grid, I simply counted 3. 3 that were the same length as the width of each of these lines. So I'm going to do 1, 2, 3, 1, 2, 3. So now I have made a grid. You could have also gone the other way around. You could have started with the 3 first, 1, 2, 3, and then done the length with the 5. It's going to give you the same exact grid. So 1, 2, 3, 4, 5. In either circumstances, we can see that the total number of squares in each of these grids is 5 times 3, which is 15. If you don't believe me, pause the video, count them. There are 15 squares in each of these grids. Okay, so for today's purposes, I'm going to be focusing on this one over here, just for the example. Okay, so in that first grid, or in that first fraction actually, we're going to shade in 2 out of the 5 rows. So I'm going to shade in 1, 2 out of the 5 rows. So let me get my highlighter right here. And I'm going to shade in 1, and 2. So there we go. I shaded in 2 out of the 1, 2, 3, 4, 5 rows. Okay. Now, let me look at the other fraction. And here I am going to shade in 2 out of those 3 rows or columns. So I'm going to shade in 1 all the way down, the whole column, and 2. So notice how I've shaded in all of this. Okay, so now we're going to ask ourselves how much is overlapping, where it's both blue and it's also pink. How many squares are shaded in both blue and pink? And so we can see that it's these 4 squares right here. These are both blue and pink. All right, so we have 1, 2, 3, 4 out of our total of 15 squares. Wait, isn't that the exact same thing that we got over here? 4 15ths, 4 15ths. And so what you're seeing, ladies and gentlemen, is that whenever I make a grid using fractions and I shade in according to what the fractions tell me, what we're going to have overlapping is going to be the same as if I had multiplied those 2 fractions. Now, am I going to ask you to do this for every problem? No, I'm not going to do that. But I do want you to understand that relationship, that when I make a grid using fractions, whatever is overlapping is going to be the same as my answer as if I were going to be multiplying those 2 together. All right, so having done that, let's move on to the next one. And this is actually number 4. This is one of our actual problems. So just like before, let's multiply this out to see what our answer is supposed to be. So we have 3/4. Sorry, we have 3/4. 3/4, I'm doing it here on the side, times 2/5. Okay, so when I work this out, I get 3 times 2 is 6, and 4 times 5 is 20. 6/20. And while that is the answer, we do need to simplify that. We always need to simplify. And I can divide both of these by 2, which is going to yield 6 divided by 2 is 3, and 20 divided by 2 is 10. That is simplified, so my answer should be 3/10. 3/10. Okay, so with that in mind, let's do the exact same thing we did before. Again, this is number 4 from our textbook. This is one of our homework problems. So let's make 4. Let's make a line that is 4 of these lines long. So 1, 2, 3, 4. That's what I did here. We have 1, 2, 3, 4. All right, and we're gonna shade in 3 of those rows. So I'm going to shade in 1, 2, and 3. 3 of those rows have been shaded. Very good. Let's do the same thing with the second fraction. We have 2/5, so we need 5 squares. 1, 2, 3, 4, 5. And I'm going to shade in 2 of those columns. So we're going to shade in 1, 2. And so again, ladies and gentlemen, we're going to ask ourselves, how many of those squares are shaded in both blue and pink? So we can see that all of these here are, which would be 6 out of the total of 20. Now, this is not the same yet, but because I have not simplified it. 6 divided by 2, 20 divided by 2, that's going to give me 3/10. Just as before, I got the same exact answer. So again, having done number 4, that's it. This is the only problem in our homework that we have to do like this, but I want you to realize that relationship. When this comes up again, and it will, not very often, but it will, I don't want you to be surprised. We have one of the fractions is one side of the grid, the other fraction is the other side of the grid. We shade in according to what the numerator says, that many out of that many. 3 out of 4, 2 out of 5. And whatever is overlapping, that would be the same as if I multiplied both fractions. Very good. Moving on. Even though we don't have to do numbers 2 and 5, there are two truths that I want you to understand. So number 2, if I go to number 2 actually in our textbook. So here we are, number 2, and let me zoom in. And number 2 reads, which is the most accurate statement about the product of a fraction and a whole number? Firstly, ladies and gentlemen, product means multiplication. So we're going to be multiplying a fraction and a whole number. So let's do this. Just pick a fraction, and specifically we're talking about a proper fraction. So we're going to pick a proper fraction. In this case, I'm going to pick 2/3. It's a proper fraction. You can pick any proper fraction, but I decided to use 2/3. And a proper fraction means that the numerator is less than the denominator, so 2/3. And we're going to multiply that times a whole number. So you can choose anything from 1 to infinity. I'm going to choose the number 6. So let's go ahead and multiply these together. In fact, I'm going to rewrite them like this. 6 times 2/3. All right, remember that a whole number is always over the number 1. So let's go ahead and multiply the 6 times 2 is 12. 1 times 3 is 3. We can simplify these by dividing by 3. 12 divided by 3 is going to be 4. 3 divided by 3 is 1, so therefore my answer is 4. So what happened, ladies and gentlemen, is that I started with 6, and when I multiplied it times the fraction, it became 4. So it got smaller. So when I multiplied a whole number times a proper fraction, which remember, proper fractions are always less than 1. You know, I don't have a full pizza, I don't have one whole. It's only 2 out of the 3 pieces that I need to make a whole. So this is a proper fraction. It actually got smaller. The whole number got smaller. Okay, so let's look at our answer choices. So with that in mind, so again, we went from 6 and it became 4 when I multiplied 6 times 2/3. So when I multiplied a whole number times a proper fraction. Okay, so let's see what we have here. It is less than 1. Did it become less than 1? Nope, it did not. Not necessarily true, okay? It is less than or equal to 1. Again, it is not less than 1. It is definitely not equal to 1, so that's not my answer. So it is less than the whole number. Yes, this is actually true. 4 is less than 6. It did get smaller, okay? And D, it is equal to or greater than the whole number. This is definitely not true. So the answer would be C. But again, what I want you to see is that whenever I multiply anything, not just the whole number, but anything times a proper fraction, the original number will always get smaller. Even though we're multiplying, it will always get smaller whenever we are multiplying times a proper fraction. Okay? So with that in mind, let's go to number 15. And number 15 reads, which is the most accurate statement about the product, again, we're multiplying, of a number and an improper fraction? A number and an improper fraction. So now the numerator is going to be larger than the denominator. Larger than the denominator. So let me go over here. Now let's do number 15, and notice how I've already picked out a number, that number being the number 2. So the product, multiplication, of a number and an improper fraction. By the way, let's remember that improper fractions are always bigger than 1. They are greater than 1. Okay, if this was a pizza, I would need 2 pieces to make a whole pizza, but I have 3 of them, so I have a whole pizza and another part. Okay, so it's more than a whole pizza. Okay, remember improper fractions, and for me to show you that, remember we can change this into a mixed number. Not that we need to, but I just want to show you something. So this is the same thing as 1 whole pizza and yet another half. So it is greater than 1. It's not just 1, it's not less than 1, it's 1 and something else. So it is greater than 1. Okay, so let's multiply these together. So 2 times 3 is 6, and this is 2 over 1, right? And 1 times 2 is going to be 2. And I can simplify these by dividing by 2. So let's divide by 2. And that's going to give me 3 over 1, which is 3. Interesting. I started with 2. That's the number I started with. I multiplied it times an improper fraction, and it became 3. So this time it grew. When I multiplied my number times an improper fraction, a number that is bigger than 1, my number actually grew. So let's look at our answer choices. So so again, we started with 2. We multiplied it times an improper fraction, 3/2. So it's bigger than 1. This is a number that is bigger than 1. And it gave me 3. So it got bigger. It grew. So was it less than 1? No, I started with something bigger than 1, ended up with something that's even bigger than 1. It is less than or equal to 1. Again, that is incorrect. It is greater than 1, but less than the number. It is definitely greater than 1, but no, it didn't get smaller. It's not less. So D, it is greater than the number. This is correct. My answer grew. So again, if I multiply by something less than 1, my number is going to get smaller. If I multiply by something greater than 1, like an improper fraction, as I have just done, it's going to grow. It's going to get bigger than what it was. All right, ladies and gentlemen, that is pretty much it. Please do your assignment. I am still having issues with some people submitting and uploading a picture to their OneNote notebook. If you have questions about that, please come see me. I will be notifying parents soon. I was planning to do so already, but I got really busy this weekend. But you will be hearing from me. More importantly, let's focus on today's assignment, and I will see you soon.